Okay, welcome to Algebra 2, Semester 2, Unit 12, Section 7.2. Okay, we're going to talk about exponential decay now. So, to show you what decay means, you use this a lot in science, especially with like radioactive materials. They might look at an atom and see how long it takes for the atom to completely disseminate or decay. So let's just pretend that that's an atom there. It's a nice chocolate bar. Let's say that we're going to practice decay. So when you come to class tomorrow, the first person in the door, I give half the chocolate bar to. So the first person gets that, half. Now, the next person in the door gets half of that chocolate bar. Okay. The next person in the door gets half of that chocolate bar. The next person in the door gets half of that chocolate bar. Now my question for you, will there ever be a student that doesn't get any chocolate? The next person gets half of that. The next person gets half of that. Now I may have to get a laser cutter, but theoretically, I will never end up with the student not having any chocolate, because it never hits zero. We'll always have half to cut from. Reminder, the first student got a whole lot more than anybody else. They got that half. The second student got that half. The third student got that half. Move it beside it. The next student got that half. The next got that half. The next got that half. We're getting pretty tiny, but exponentially, you'll never hit zero. You'll just keep cutting it in half. That is exponential decay. Okay, so what is the asymptote for the parent function? Well, let's go back to what the exponential decay parent function was. The exponential decay parent function was y equals 1/2 to the x. So when x was to the 0th power, it was equal to 1. But as we went to the right, every value became half of the previous one, just like our candy bar, but it never ever hits 0. So our asymptote is y equals 0. What does the asymptote look like algebraically and graphically? Well, graphically, I'll just show it up here since we've already got it drawn. It's like that, and I ask you guys to highlight that asymptote line showing me it's never going to touch there. Okay? Now I would like you to extend this decay line out here so that we see it in the negatives as well. Now, algebraically, we could simply write that 1/2 to the x will always be greater than not equal to 0. No matter what value we put in there, it will always be greater than, not equal to 0. What is b referred to as in the exponential decay function? Well, remember, we're talking y equals ab to the x. So in this case, it's 1/2. But what does that 1/2 really get termed as when we're talking about this? That is your decay factor. Just like in class yesterday, you learned, or today, you learned that in the growth function, the b value is the growth factor. In order for decay to occur, what restrictions are there on the b value? Well, it has to be less than 1. It has to be greater than 0. Okay? It has to be less than 1, greater than 0. Because if it's at 1, there won't be any growth or decay. And if it's greater than 1, there will only be growth. Okay, so now I want you to come down and graph these. You can stop the video and graph these on your own if you want. This is all review. And then turn it back on. Check your answer. Stretch factor of 3, that would be your a value out front. Your b value is 1/2. And it shifted down 4, so that would be a -4 this way. We take our parent function, was going like this, just a sketch of it. Now we're going to stretch by 3 and we're going to go down 4. So our asymptote moves down 1, 2, 3, 4, right along there. But we will stretch, instead of crossing here at 1, we're going to cross at 1, 2, 3. So it should be a -1. Let's verify that. We plug in 0, 1/2 to the 0th power is 1. 1 times 3 is 3, minus 4 is -1. So right there we have it. Okay, let's plug in the value 1. 1/2 to the first power is 1. That makes 1/2 to the first is 1/2. Times 3 is 1.5. 1.5 minus 4 is -2.5. Okay, let's go to the -1 now. 1/2 to the -1 is 2. 2 times 3 is 6. 6 minus 4 is 2. So there's our stretch factor, showing up like that. Just stretches that curve a lot from what the parent curve had been. I would like you to take that highlighter and highlight your asymptote and label that ASY. Okay, just like you've done previously in graphing for me. Okay, next one, shrink factor of 1/2. B value is 1/2. Shifted to the left 3, and it's reflected. So let's think about our parent graph. Our parent graph for this would have been crossing there, going 1/2 again, going like that, just like the parent graph on the other one. All parent graphs are the same. So now we're going to shrink that, bring it down 1/2 again as close. It's going to look something like that. But then we reflect it, so now it's over on this side. And on top of that, we're going to move it to the left 3. So we move it 1, 2, 3 to the left, and we draw it over here. You can go ahead and plug in some values and make sure that that's correct. Go ahead and highlight your asymptote. Remember, the k value sets our asymptote. Since it didn't shift, didn't have a k value out there, our asymptote didn't change. Have a great night. We'll see you tomorrow in class.